Can you guys hear me well? All right. Welcome to our second Kubernetes birthday party. It's been exactly a year since we started here in Google, and I'm very excited to be back 1 year after and in the same spot. So I see a lot of veterans here already, but at the same time, I see a lot of new faces. Julia, my co-organizer. So we have a few quick announcements. So everybody who needs a toilet, you have to go this way on the left.
Men's are this way, women's are on this.
Yeah, but you have to walk all the way around. So yeah, and what else? Anything else for the? Okay, yeah. So unfortunately, we didn't size pizzas very well. So I know some of you didn't get a slice. So we're gonna have a break for cupcakes, and we're gonna get another round of pizza. So don't be worried about that. Yeah, and we at the same time want to say thank you to Google for organizing Pizza Beer and inviting us to this awesome place to do. CloudOps as well, the ones that's actually organizing the meetups itself, and all our sponsors that you already probably saw during the year. So Days actually recently become Microsoft, but the rest is still in place. Yeah, so if you want to be like getting all the slides from all the meetups, we have a Kubernetes Slack channel where we're posting all of the slides from Toronto, Quebec, Ottawa, and Montreal. So you can join there, and we have a channels for different tracks. So we recently had a Kubernetes Meetup in Ottawa, and we had a Prometheus guy, the one that's doing monitoring. So he said, like, everybody who wants to onboard on Prometheus, he will be helping, to answer questions. And I think we have a guy for OpenShift now. And in general, I think we should build like interest in different groups. And there is Kubernetes channel, like the real one. It also exists, but there's like, I don't know how many thousand people right now there. So nobody's kind of getting answers back. So here we can try to follow up on each question. So please join, take a picture. And if you didn't get a picture, I'll try to put it the slides later about that. So you'll just automatically get registered. You don't have to get anything, just go in there and you should be in. So we had a lot of complaints for the people that every talk they attend or the workshops, they all like, basic Kubernetes, and people want to kind of get like day 2 of the Kubernetes and do CI/CD monitoring and other stuff. So we build the workshops. Right now it's mostly myself who's running them, but we're probably going to expand if there'll be more need. So if you're interested to attend any workshops, you can basically barcode, or there is a link there. So, and we just recently partnered with Google and Azure, so we're going to be doing also the like specific cloud provider training. So if you want to run your Kubernetes in the Google Cloud or in Azure and Amazon as well, you can also attend this type of like specific workshops for the cloud provider. So yeah, so we have today 4 talks actually, not 2. I don't know. So that's why we want to order more pizza, because I don't want people starve listening all 4. So we have, thanks. So we have Kubernetes 1.7 update. We have talk about Kompose. So people, like developers especially, who is doing Docker Compose, they want to move to Kubernetes to run in production. There's going to be talk from the Red Hat, like one of the main community developers of Compose. And he's going to be talking about some cool tools. Then we're going to have presentation from the Kash. So they're using Kubernetes in production with GKE. It's a Google container engine. So he'll be talking about how they're doing it there and what problems they have and how to, they're going in the future to improve that. And then at the end, we have a special online guest. Unfortunately, he couldn't make it here from Montreal. He works in Google, Patrick. So he will be like doing a live demo of GKE. So that way you can have like slides and also the demos. So yeah, I can start with Kubernetes 1.7. Unless you have any questions, I can probably go ahead. So also we have some swag, unfortunately not a lot, but if you have a good question, I'm going to be sharing some swag with you. So yeah, so Kubernetes 1.7. So about a couple of weeks ago, we had a release, and there's a few interesting things I want to talk about. So if you can see, I don't know actually who is using Kubernetes 1.6. Okay, good. And 1.7. One. Okay, good. Yeah, it's too early. I mean, not all the tools that people using, like for example, in Amazon tool CloudOps is not ready, but GKE already announced 1.7, so like some people already switched. So if you look into this graph, so what it tells us in Kubernetes, if you're running like 1.6, 1.4, or 1.2, those are like even number releases. They have a lot of stable features, and the ones like 1.7, 1.5, 1.3, they usually have a lot of new features that in alpha. So that's what exactly happened with the 1.7 release. There's a lot of exciting features, but they're not production ready. And if you remember, if you have something in alpha, this is like very risky to run in production. Most probably you don't want to do it, but some people are taking risk and running it. But you have to be aware that it might change completely the name. The API might change. So when you do upgrade, you have to change all of your manifests, and that's how it goes. The beta, I know a lot of people using beta in production, but still there is a chances that there will be some small improvements. And then stable, this is like production ready supported feature from Kubernetes. Yeah, so who remembers like what was the most coolest features in 1.6? I have some presents, as I said.
Role-based authentication.
Role-based, RBAC. Okay, cool. So anything else? You can Google still, I think. So we had RBAC.
Node affinities or pod affinities?
That was there before.
No, but it wasn't the same. No. It wasn't the same way. It was alpha before, and then they changed it completely in 1.6 how it works.
Okay.
So we went through that. We're gonna talk about that.
Okay. Yeah. Anybody else?
Stateful sets.
Stateful sets, what? They were there, but like. Okay. Yeah, anyways, so we have Excel and L's t-shirts, but I can give you sock probably because you already have a t-shirt.
Yeah.
Just to have a full set.
Nice.
Yeah, I was very excited in 1.6. There was like dynamic provisioning, so you can actually dynamically provision your storage before you have to like call storage guy telling you, hey, can you create a volume for me? And then I'll do PV-C and then create a PV. So now it's like with dynamic storage provisioning, you can provision, let's say, I'm using SolidFire or I'm using Google Cloud or Amazon EBS. It's automatically going to create a volume for you. So, all right. Yeah, so 1.7, what was new? I'm going to be basically discussing myself. And there was a blog post actually in Kubernetes blog channel or Kubernetes blog website. But some people don't like to read, they like to listen. So I'm going to be covering some of them. So there was a lot of work being done. I mean, Kubernetes from the beginning in 1.1, it's already been production ready. So you can do like things like replication controllers, scale your application. You can do rolling upgrades with them, with deployments. And there's like those nice features that people have been using from the beginning. But then like the complaints were like it's not security compliant. So like things you're storing in the CD is like wide open. So if somebody hacks your CD, you can see all the passwords and secrets and stuff like that. And there was like a lot of stuff that people want to improve. And actually Red Hat was doing a lot of help on that side. There's also things like, in the beginning, everybody was telling that Kubernetes is to run stateless application. So the websites, but the databases is something else. You're still running in VMs. So there was a lot of work done in the stateful sets and stateful applications. So we're going to discuss that. And finally, Kubernetes is trying to work nicely with all tools, or like it's a Cloud Foundry, or that people want to have catalogs. So there's a lot of work that has been done in to do the extensibility of Kubernetes. So the security part, we have the network policy API became stable. So actually, I didn't ask how many like really new to Kubernetes today here, like the first timers. So yeah, so I'm probably going to explain what is network policy. So network policy, if you don't have it, basically all your pods in the cluster talk to each other. So if you have some of the, some of your Docker containers, if you don't do scanning, for example, it has some vulnerability. It can actually go to all of the pods and do some bad stuff. So with network policy, you can actually create a kind of a rules telling like my front end can only talk to the API and my API can talk to database, or let's say you can say my namespace can only talk to each other but cannot talk to another namespace. So this feature is available only with specific networks CNI plugins. So if you use Calico networking, or if you use Weave and a few others, like if you using like Flannel, it's not going to work. So it's only, you have to know, like Calico is the most popular and Canal is like second most popular, and Weave networks. So those, if you have those type of networks, you can use network policy API. And this is like stable right now. This feature is like people super excited because like etcd was like wide open. So now they started to do work. So all the secrets is going to be encrypted in etcd. So I know a lot of banks are very happy about this, but this is still alpha, so this might change. But you still can, start trying to use this feature. Kubelet TLS bootstrapping. I don't know if anybody using kubeadm. Okay, yeah. kubeadm is like, I don't know if you know Swarm in Docker. So you do Swarm init, Swarm join. So this is the same functionality, like you want to deploy Kubernetes cluster with 2 commands, well, actually 3 commands. Like you do kubeadm init to start the master node, then you do kubeadm join to join the worker nodes, and then you want to create networking with CNI plugin. So it's 3 commands and you're up and running in Kubernetes. So kubeadm is still like alpha, but there's a lot of work to be done to be like, so it's going to be HA very soon, and having encryption TLS. So that's the Kubelet TLS bootstrapping will help to make it more secure. And you should probably look more into using kubeadm. I know a lot of companies using kubeadm for CI/CD part, but the real Kubernetes cluster is used by something more secure and something more HA. But in the future, kubeadm will be useful, stable, and I think everybody should look into that. Node authorizer and admission controller. So those are, again, something to have your pods more secure. So before you can also see the secrets in the pods and stuff like that. So right now, those part is going to be more secure as well. Any questions on security? No? Okay. Cool. So stateful workloads enhancements. So stateful sets. So before, as gentleman said, we had a feature called pet sets. It's now called stateful sets, and it mostly work for deployment, but you still need to do upgrades and stuff like that. So they did enhancements to do the rollback and upgrades of stateful sets. So stateful set compared to like normal, container with a persistent volume where you can deploy like a simple database, for example. Stateful sets allows you to run clusters like Percona cluster or Galera cluster or Cassandra's, stuff like that. So it really allows you to run clustered solution with like 1 click of deployment. You can run like 1,000 Cassandra nodes, and you can upgrade it, you can downgrade it. So it's pretty cool. Local storage, another feature that people were looking into. So in the past, we were using kind of NFS, or we're using like something like cloud provider provides you to use. But sometimes people, let's say, running Kubernetes on virtual machine that has solid state drive devices, like very fast one, but they were like sitting there doing nothing. So now you can have local storage for the things like if you want to use big data workloads calculation, and you just want to, like as a developer, want to use the underlying storage, this feature will be available. I don't know if it's going to be possible to really use it for other things because local storage is not migrating easily. So it's going to have a certain limitation and certain use cases. Enhanced updates for daemon sets. So I don't know, daemon sets, somebody's using daemon sets, but yeah. So daemon sets allows you to run container on all the nodes in the cluster. So you just say, I want to run this pod and it's going to be running everywhere. For example, you have Elasticsearch and you want to run Fluentd agent on each node, you will use daemon set. So it was very nice to use them, but there was a problem to do upgrades and rollbacks. So right now they added this functionality to Kubernetes. There's a lot of plugins added. I don't know if there's any OpenStack guys in the room. So like in OpenStack, we had used to be like every release we had a new storage driver added. So right now in Kubernetes, the same thing. Like they added NetApp. Right now StorageOS, but like they keep adding new and new storage plugins, so you can use any type of storages with Kubernetes. And finally, extensibility. So container runtime interfaces enhancement. So basically, what was I going to say? Yeah, so we have a new RPC call channel, so it allows to work much faster. And I don't know if anybody follows the Docker that they created Moby project. And then Moby, Docker used to be like one big monolith, so now split it for the small pieces. So containerd is like very lightweight Docker container without all of this functionality. So Kubernetes is going to be able to also run containerd. And before we had also, for example, Rocket support from CoreOS. And there's like anybody has a container can actually run with Kubernetes. So not only Docker, but other containers. But of course, Docker is so far is the most popular container to run with Kubernetes. So I think people were like, no, yes, I'm using Kubernetes to run containers, but I have to run my virtual machines somewhere else. So they were very interested to run virtual machines as well with Kubernetes because it's like very easy. You don't have to know how Puppet works, how Ansible works. So there's two companies that working to adding virtual machine support on Kubernetes. So Vertlet, I think it's Mirantis is doing some work on that, and also Red Hat, I think, working on one of them. And Fracti. So those are like you can basically using manifests from Kubernetes, and you can actually schedule KVM virtual machines running in Kubernetes. So sometimes you just have that app, that monolith, very old one, you want to run in VM, so you can run it side by side with Kubernetes containers. I think it's a very cool feature. There is a lot of improvements. So like API aggregation at runtime, this would allow to have like service catalog available with Kubernetes. And I don't know if anybody using operators. Okay, one, yeah. So operators is like very advanced feature of Kubernetes. You can deploy, let's say, like monitoring, or let's say etcd clusters with operators. So operator allows you not only to deploy on Kubernetes, but using Kubernetes API, it allows you to do scaling. It allows you to do upgrades, so you can maintain your application lifecycle within Kubernetes itself by just using Kubernetes command line, and it's very easy. So a lot of work has been done by CoreOS in this direction. They have a lot of operators. So like Prometheus as well, monitoring system you can deploy with operator. So right now they're doing some changes how things work. So before they were using third-party resources, and now they're switching to custom resource definition, CRD. So there's going to be some transition for all of those. So, but the TPR is still going to be supported in 1.7 until 1.8. So yeah, there's actually much more features in Kubernetes been added in 1.7, and we're trying to have like a webinar online. So you might receive an invitation. Like one of the Kubernetes project managers kindly like agreed with us to do some workshop. Sorry, not workshop, the webinar. So yeah, I think I'm pretty much good. I don't know, Rancher guys, if you remember, they were here. We did integration with cloud.ca to run the Rancher thing. I don't know if anybody using cloud.ca here. Probably not. Okay. Yeah. So I think I'm done from my side. We have, next presentation is from Red Hat on Kompose. If you want to start switching, but like if you have any questions, 1.7, it's a good time to ask and get one more t-shirt and maybe something like that. Questions? No questions? Wow, nobody wants a t-shirt. Oh yeah, okay.
Yes, so what's Kubernetes doing to work with Hadoop and...
Okay. We have L's and XL's, so I think L is good. You're going to be the next one. So the question, what is Kubernetes is doing to work with the big data? So I just talked about local storage. This is one of the examples. And as you know, in Kubernetes, it's a community, right? There's no company that actually controls Kubernetes, but in the beginning, Google was kind of donated this project to open source it. So there was most of the Google developers who were contributing to it, but right now, Google is like less than 50% contributions. So in terms of like big data, the way the community work, we have different special interest groups. So if, let's say, you're interested with networking, you're going to be joining SIG networking group. If you're working with the storage, there's going to be SIG storage group. So we have a SIG for big data, and you can join there and discuss. I think they're going to have more and more demos because big data, at the end of the day, it's application.
Yeah.
So we have SIG apps team that working with the Helm, for example. And in the beginning, they said we're going to be covering big data, but we see that there's a lot of complexity, and you need to have special guys who knows like how Hadoop works and stuff like that. So this group is going to be generating a lot of features in the future, we think. So like local storage is one of them, but there's more things to come. So yeah.
So for the Spark on Kubernetes, not in container, but natively on Kubernetes.
Not in a container?
Not in
Well, you mean like
Mesos or Yarn.
if you want to run Mesos on Kubernetes, you mean?
No, running Spark on Kubernetes.
Okay, running Spark on Kubernetes. Yeah, so there is like actually, if you Google, there is several trials people were running, and we have Helm chart for the Spark. It's not like stable chart, so it's probably not ready for production, but if you Google Helm Spark, it's going to be like beta version, and you can use with a certain limitation. But as I said, like we have this special interest group that is working specifically to address, those limitations to run. So.
Are there any PubSub functionality coming to Kubernetes natively?
PubSub?
Or is it going to be running RabbitMQ on it forever?
Well, I mean, if you're running in Google Cloud, let's say you have this out of the box, but this is more for messaging, right? Yeah. I mean, you can install any application, like, I don't know, like, what is it? Yeah, RabbitMQ or any MQ. Yeah, so actually, if you go to the Helm charts, you'll find them there, and like, you don't really need to run them with the persistent volumes even sometimes. It depends on the use case, because you just want to have the available. So, yeah. Okay, are you ready to go? Yep. So I have 2 t-shirts more, and then I'm done. Okay. So this is good. Yeah. Thank you, guys.
So I work at Red Hat. Basically, all day, all I do all day is work in Go, work on Kubernetes, work on Kompose, contribute a little bit to like Docker/Moby, same as Docker Compose. And basically, what I do is I work on the developer tools team, and I try and enhance the usage of like Kubernetes/OpenShift, just like containers in general at Red Hat. So my presentation is going from Docker Compose to Kubernetes and beyond. So if you don't know any of these, I think you're in the wrong place. Must know Docker. Some of you may have used Docker Compose just for like development, and of course, we're all here for Kubernetes. So the typical experience for a developer is that we start with Docker or Moby. So how in the world do I get started? You basically run this one command as just a plain old Jane example showing, okay, this is what I could do in a Docker container. I could have Nginx running in, I think they use Debian as a backend, I don't know. Or they use just the standard C binary and do it from Docker scratch, from build scratch. But anyways, this is the first example people usually show to how to run a Docker container. So what about PHP website? Basically, you run your database, MySQL, and then you run Nginx. Of course, you have to pass in your HTML files, link in the database. So for this is a PHP application using Apache. So in order to communicate to the two, you spin up 2 Docker containers. Now, next is how do I make this easier? Like, I don't want to run these 2 random commands. I want to run it into like a nice little YAML file. So they made Docker Compose. So this new declarative format, basically, instead of having the commands, you have this neat little YAML file, and you're able to define all your services, like pass in, like, I don't know, your environment variables, if in case you wanted to use a different environment variable file. Like, it's really cool for bringing up multiple containers at the same time. Of course, if you just want it running one container, that doesn't really matter. But like, for example, linking it, like you don't have to do that anymore because Docker Compose version 2 does it automatically. All these containers are able to communicate with each other. So they really simplified the format. So if you haven't used Docker Compose before, you literally just do Docker Compose up with that declarative YAML file, and boom, like you have a PHP application with MySQL database. Okay, now what? Now what do I do? Oh, well, this is the only meme, I promise. I don't have anything else. So we have a lot of other container orchestrators. We basically, Docker Compose is a nice development way of testing your application. But what do we do now? Like, how do I go from development to production? Well, there's Kubernetes, OpenShift, Nomad, Mesos. They added Docker Swarm, then they updated the Docker Compose format. Shipyard, Rancher, I think these now by Microsoft, they have Workflow. I think that runs on top of Kubernetes. I don't know, even them might be a container orchestrator. Everybody wants their own now. But basically, we have Kubernetes. So because I'm at the Kubernetes Meetup, I'm going to talk about Kubernetes. So why? I don't think I need to really explain why. There's a ton of stars. That's all what people care about nowadays. So it's robust. It was Borg before. Now it's open source. Don't really need to talk about that. But looking at Docker, if you remember Docker Compose, you could go, now we want to switch from this YAML file to all these Kubernetes artifacts. Like so many, I had to put it to like font 6 and squeeze them all in. How do I go from this to that? Well, we Skipbox created a tool. They are acquired by Bitnami. So they initially started it. There's some contributions from Google. What this basically is that it's a conversion tool going from that to all those Kubernetes artifacts. That's what I'm going to talk about. So basically, all you need to do is take that Compose file, run Compose up. We call it Kcompose because people really get confused between Docker Compose and this. And bam, you're there. So hopefully this works because I had Minikube set up and I did Minikube delete before. So let's do the live demo. Okay, so just started. Hopefully everybody can see that. There we go. Just started Minikube. You're not supposed to see that. But basically, I have an example Docker Compose file. This is the standard Google example, basically the go-to. It just uses a Redis slave master and uses the front end. It's the guestbook example, if you ever ran that before on Kubernetes. And I added this little thing right here because That's one of the few things that we can't really convert from Docker Compose to Kubernetes. I'll talk about this a little bit later, but if you've used Docker Compose before, you're able to declare all your containers, like have your environment variables, opening all the ports, so this front end could communicate to it, and get a host from DNS, so this PHP application is able to find Redis and able to connect to it. So I'll start with the demo. So all you need to do is, I have Compose on my system. Side note, we just reached 1.0, woo. So I'm gonna run Compose up, and bam, it's already deployed to Kubernetes. So I'm gonna get the pods. All right, so it's now running. It created all the Kubernetes artifacts and in the background talked to Kubernetes via the API, and deployed it. So now I'm gonna do minikube service front end. Hopefully this works. All right, saw an error, but I think that's minikube. So now we have the guestbook example. This is usually the first example you run with Kubernetes. Enter foo bar, all works. So, yeah, like that's my ad block. Yeah, so there it is. So we can run Compose down now, and it will delete the service. Let's watch it get terminated. Okay, it's all terminating. So basically, all you need to do is run Compose up. But of course, if you want to actually get the artifacts, you would run Compose convert, and it'll create all the YAML files. Okay. And any questions? Am I moving a bit too fast? Okay. All right. Let's back to the slides. Oh, yeah.
Was here actually.
My question is this gonna work with the Helm chart or just gonna replace Helm chart, whatever?
We have compatibility with Helm, but like not really, because with Helm you have all those charts. You input your environment variables, and it goes from like this chart, which is sort of like a Kubernetes artifact, to like generating these Kubernetes artifacts. But it's good because it's like within the Kubernetes ecosystem. But no, I don't think this is to like replace Helm. This is basically to like get everyone to move from like Docker Compose / Swarm to Kubernetes, something more production worthy than Swarm. That's my opinion. Don't quote me on it, but yeah. Oh, over there.
You were able to manage .env files?
What files?
.env. So, like for example, if you put environment variables.
Yes. Yeah. So if you supply the environment variables, Compose will open it up, or it will actually take it from your host machine. Like if you have the environment variables set on your host machine, be able to take it from there. But yeah, we have support for that.
Will it create a config map for you?
I'm not too sure, to be honest. Not about config map. I'll have to look into that. Yeah.
Yeah, actually, like I have a few questions as well.
Yep.
A lot of people, like I saw, developers, they don't really kind of care about the security part. But when there's somebody else who's responsible to run the application in production, when you're using Docker, people putting everything in environment variables, and it's basically if you put the same way in Kubernetes, you can actually using kubectl, you can see all passwords and all environments.
Mm-hmm.
So, is there any way that Compose know that this is a secret or this is a service? Is there any way to kind of
there's an open issue for that. So I'll be talking in the last half of the presentation about how we get over those limitations of Docker Compose, because there are no secrets in Docker Compose at the moment.
Yeah, and then the one more question is,
Yep.
I'm gonna get T-shirt as well, or?
Oh yeah.
No.
This was at the Seattle Summit, so.
So yeah, if you basically have service, you have let's say 4 ways to you can have a node port, you can have load balancer, you can have ingress. Is there any way you can actually specify in the Compose file that is going to be transferred, or how?
Yes. So you know how I talked about that part that I'm going to talk about later on the YAML file? It's that. So basically, you're going to get over some Docker Compose limitations, because not everything maps from Docker Compose to Kubernetes. You supply it with a label. So you could say node port, cluster IP, Ingress support as well, so you're actually able to specify a domain, and Kompose will create ingress. Yeah.
Okay.
So.
For example, like some people are still running in 1.5, 1.4.
Yeah.
Some people running in 1.6. Some like 1.7 already.
Mm.
How you would be able to tell to Docker Compose to create specific manifest for specific version?
We are out with that. So right now, we only support 1.5, 1.6, and 1.7. 1.4, like, basically, you just need deployments and services. We have support for daemon set, and we're adding support for, like, stateful sets and jobs and such. But basically, if you've used an app like KOps and they have that compatibility matrix, we're adding one of those. Because basically, it's getting to the point where it's all Kubernetes community's pretty fractured of what version you're running. So, but eventually, like we'll eventually have like specific versions you could convert to.
So,
okay.
So there is Docker Compose, but you never mentioned anything about Docker Stack. Will that actually be supported?
This isn't in my slides, but basically we removed that because there wasn't much traction going on. Basically, they have an open issue for Docker on the Moby repo, whatever. So basically, they have an open issue that no one's talked in since 2016 about Docker Stack because distributed application bundles are still in experimental. So we ended up removing the support because no one was using it. But yeah, like I don't know if that answers your question. Like, yeah, you're using it. Okay. All right, got one person.
One question. Why do you need another tool and not make kubectl, for example, to know how to process a Docker Compose file and with one tool and not another one?
So you mean like
3+1 here?
Yeah. So you mean like implementing Docker Compose into kubectl? We did that for I'm at Red Hat, so we did that with OpenShift. Funny enough. And in OC, and we actually had like OC import, I think import file like Docker like Compose or something like that. We ended up splitting that out and taking that code, and we realized, this company called Skipbox is working on Kcompose. So we ended up taking the code from there and implementing it to Kcompose, and then putting it through the Kubernetes incubator. And then now we just graduated the Kubernetes incubator. So instead of having it in kubectl, we actually have it as an own separate project within the Kubernetes community. Basically, too much code to handle in one like binary.
Yeah, I think actually that's could be the reason because they're trying to remove all extra stuff from Kubernetes because that can be added easily because when you do testing, there's so many features, and if something is failing, there's going to be bad reports and stuff like that. So they want to remove something like out of the code. They did with the networking. We have CNI. We did it with the storage. We have, we did it with CRI. So they're trying to remove all these extra components to test so that the Kubernetes itself can be released faster. But I agree with you that it would be really nice to have it.
Yep. So yeah. Yeah. So the question was about like the plugin support as well. I think that was just added to 1.7, right? That was one of the new features, like kubectl plugin support. Yeah. So yeah, that's another way to like implement this. But you know what? Let's hold on to questions because a lot of these could be answered after. I'm going to be talking about this too. So let's switch back to the slides. Oh, all right, perfect. So why Compose? I think I answered a lot of this in the questions. So moving from Docker Compose to Kubernetes, dev environment to production, all the defaults. So we try and cover as many like niche and edge cases as possible. So we have like standard defaults of deploying to deployments and services. We have other parameters, so deploying to daemon sets. Looking at stateful sets and stuff like that. But it gets you 95% of the way there. If like your application doesn't work with Compose up, like we understand, just do compose convert. and see what parts you could fill in, see what your application actually needs. Like, I'll go over this with volumes, because we have a lot of troubles with volumes too, because it's going from like mapping your host's volume to Kubernetes, which is like persistent volume claim. Anyways, so main use cases, I already covered that. Basically making a proof of concept, going like using your Docker Compose environment, seeing how it'll run in Kubernetes, and simplifying Kubernetes deployments. Some people and some companies that we've talked to basically just use Docker Compose, and they don't even need to create their own Kubernetes artifacts, because they just run Compose up, or they do Compose convert and then kubectl apply if they need to make any updates or they change their containers or whatever. So some of the limitations is that some concepts are not available. We only map to deployments and services. Of course, we have other CLI parameters. Jobs as well is the other one I didn't mention. Secrets and config maps cannot be defined yet, so we have an issue open for that. Volumes are very difficult. It's like people want to basically have all their HTML files on their host and like have it in the same folder or whatever. So when they run Docker Compose up, so mapping that to Kubernetes, like you have to have a persistent volume claim, and not all keys are convertible. We actually have a conversion chart, and something like 70% of the keys we can't even convert, because there's no one-to-one between Docker Compose and Kubernetes. Like all the main ones are there, but it's all the small nitty-gritty ones. Like for example, CPU, like they go by percentage, while Kubernetes goes by, I think, like value, like some weird value for it per node. So how we basically hacked up Docker Compose to work with Kubernetes. Docker has a Compose implementation in Go called libcompose. We use that and kind of like hack around it. It's the implementation in Go, so you're able to do the same functionality as their Python implementation. So we use that to like parse Docker Compose YAML file. And we make a lot of assumptions as well. It was only until later when Swarm was introduced that Docker Compose changed. It gets really annoying when it's like Docker Compose 1 is so much different to Docker Compose 2. And then they had like 2.1 and 2.2 release, and I don't think anybody used that. Like it was like health checks and stuff like that. And then they had Docker Compose 3 because they wanted Docker Swarm support with it. And so they had the deploy key, so they moved everything around. Now they're working on Docker Compose like 3. They had 3.1 released, had 3.2, now they have 3.3, and now it's like split between Community Edition and like Enterprise Edition. So I wish everybody could just switch to Kubernetes and that's it. Another thing as well is that Kubernetes is designed for multi-node from day one. Docker Compose was for single node testing purposes. Even for like a small, like, I don't know, if you're doing consulting and you want to run some like small PHP application on a VPS, like it's for that use case. If you want to run production code scaling on like Cassandra or something like that, you use Kubernetes.
Sorry, back to the version 2 and version 3.
Yeah.
Is there any way we need to specify to Compose which version of Compose file we're using, or it's automatic?
Automatic. So we actually added Docker Compose version 3 support in our 1.0 release. So it'll map directly. We're adding deploy key support. So under deploy, you could say replicas, and then you could say like CPU share and stuff like that. So
which one working better?
Version 2. Version 2. Version 3, we're developing it more and more. It's like we've dropped support actually for minor versions because Docker moves so freaking fast, and they don't know what they want to do with Docker Compose. So anyways, let's move on. So basically for volumes, that little line there converts to all of this. So we hack it up to try and get the most standard defaults. So for here, we have like a default storage of 100 megabytes, and then basically scaling from there. So just like pretty much standard defaults for mapping to Kubernetes. That's one of the ways that we convert it. This is very hacked up, and unfortunately, there's nothing we could do about it. But I'll show you how we fix that. So we use labels as well for things that we can't map. So we have Compose service type, node port. So you could either put node port, cluster IP, or load balancer if you're running on the cloud. For my example, I'm just going to use node port. Like in the demo, I use node port because I'm just running in Minikube. And this creates the ingress as well. So basically, for stuff that we can't map or we don't have in Docker Compose, we do it through labels. These are the only 2 labels that we have. Another thing as well is the service type. I just talked about this. So basically, it maps from that node port to there. Same with ingresses, map the domain, and we create an ingress. Same with expose, map the domain, we create the ingress in Kubernetes. We can only do so much, like as a maintainer / developer working on Compose, there's only so much you could do. Like, it gets to the point where you're, okay, like, what are some other alternatives? And it's called Catch. So another name with K in the front. So basically, Catch simplifies Kubernetes artifacts. It's basically the Docker Compose version to Kubernetes artifacts, but better, I hope. So it's a simple way to just define concise applications, define only what you need, and the CLI tool will fill in the rest. It will basically find all the good defaults with deployments and services. It's simple for developers, but what better way to show you? So basically, containers, we have this standard YAML file. At the top, we have the name. We have containers, which basically maps to deployment, and then services, which of course maps to service. So we take this super simple YAML file, and we generate all of this. So I'll save questions for later, because I know this is a lot to take in right now. And a more elaborate example. Like, now it starts getting crazy. Most likely can't read it from here, but I'll show you in a bit. Basically, this is a database, MySQL, actually running MariaDB, same thing. It depends who you ask. So we have the database here, and then we have web with all these environment variables. Please don't use WordPress as your password and username. And we're able to deploy this to Kubernetes to generate all these artifacts without having to worry about it. Basically simplifying the development process and not having to worry about, okay, spec, containers, environments. Just have this nice, simple YAML file. Okay, so you essentially do catch, create, database, and web, and off you go. So another demo, praise the demo god, so hopefully this works. All right, so there we go. Hopefully this is big enough. Now, keep in mind, this is so new, we don't even have a release yet. I'm serious. Like, we have a bunch of things we need to fix before we do the release. We have this nice little demo, it works and everything, but even for mapping, communicating to Kubernetes. Compose, we use the API. Now, like we use the Go client and everything, and for this we just map using kubectl at the moment. But this is so new. Like, download, test it out. Please open an issue, or don't give me more work. I like that too. So basic kubectl get pods. Luckily I have nothing running. So I'll do catch. Oh, basic. First off, I'll show you the first example. So CentOS, using Apache. If we run this, just like kubectl. So catch, create, and off it goes. Honestly, I'm not gonna wait for this to come up, but basically enter Minikube service. I think it's, HTTPD, and you're able to access it. So, all right, this is still not up yet. It's exact same as kubectl. Taking this super simple YAML file, which defaults to deployment and services, and create it now. Oh. I think that's a bug. All right, so HTTPD. There we go. All right, perfect. So yeah, that's pretty much it. So same as with this example too. I'm not going to run this because I don't want to wait for the other one to be deleted. Exact same thing, kubectl creates -f and adding everything there. Okay, so let's move on. I don't know how much time I have left. Okay, so collaborating with the Kubernetes community. This isn't. There we go. So this is our nice little table. We go, here's Docker Compose. There's a lot of blanks. Compose, and then Kedge. So to answer your questions about secrets and everything, in Kedge, we're adding support for that. There's actually an open PR, and I think I reviewed it yesterday. But basically, we're filling in what we can't convert from Docker Compose to Compose, and then to Kedge. So for example, probes, they were added as health checks in Docker Compose in version 2.1 and 3. I think 2.1. And then Compose, we have an open issue for that. And then, of course, we define it in Kedge. Same as for secrets. We have the open PR, but of course, you can't define any secrets in Docker Compose yet. Yeah. And if you want to check it out, we just reached 1.0, like I said before, and we just graduated. There should be a Compose blog post coming out soon. Of course, the Kubernetes blog people were busy with 1.7, but I think you'll see it about next week. We have our websites and GitHub as well. We have a lot of stars on this one, so if you could go on that one and give a lot of stars, that'd be great. But just check it out. Like, seriously, instead of having to write all these Kubernetes artifacts, nice, simple, concise file that defaults to all these other deployments. We communicate a lot in SIGApps, and we're also in Slack too. Okay, that's my presentation.
Nice for the great demos. I think we should still do the round of questions, right?
Yeah. Are there any questions?
Like I still have a question actually.
Oh, perfect.
So I mean, what we're seeing right now, as you said, a lot of developers using Docker Compose because they not necessarily took training about Kubernetes. They don't know about it, but like people been using Docker for like 3 years now, and they have it on their machines, like on MacBooks, whatever. So like Kedge is not. You have to just write there, and then how are you gonna test with the Kedge? Like you have to migrate it, and then.
Yeah, there's no like with Compose, like testing your dev environment with Docker Compose, and of course converting it to Kubernetes. This is more for deploying straight to Kubernetes. But yeah, like it's basically testing on Minikube, I guess, as your development environment. But even you were talking about Minikube and everything earlier. Like using that as a development environment, it's not like there's some missing features and stuff like that when it first came out. So now it's better, but yeah, like you'll have to test it directly to Kubernetes cluster.
Okay.
Yep.
Two questions, I think. One, why can't you just merge between two tools? And another question, why do you introduce another YAML format instead of just using the same Kubernetes one, but with lesser configuration options, which you just fill in automatically? So it will spare from the developer another learning curve, and it also will prevent different developers using different tools to find actually a common language, something like that. Because what I'm seeing in the community, a lot of new tools are popping up every morning, and if you will try to actually follow everyone, you'll try to follow. You'll not be using anything.
Yeah, that is a very, very good question. Like the second question, in regards to like if anybody's ever seen the XKCD comic, there's one which talks about like there's 14 different standards, and like another standard has come up. Now there's like 15. It's the exact same thing with Kedge. Like, what's the point of using Kedge when you could just focus your time on learning all those Kubernetes artifacts? And unfortunately, I don't really have an answer for that because, like you said, the community every month a new tool comes up. We have Kedge, which is what we like, which we use to fill in the whole deploying little apps and stuff like that on Kubernetes. Then there's also KSONet, which is I forgot what it's called. Like the JSON. Pardon? Yeah. Using JSON and having everything automatically fill in and magically create all these Kubernetes artifacts. But as well, it's like learning another format to learn another format to finally use Kubernetes. And then, what was your first question in regards to versioning? Mm-hmm.
If you're controlling Kompose, just add support for how do we say a small version of the Kubernetes language, and so in the long run it will make the community only beneficial because every developer will talk the same language. Every developer eventually understand what the format of Kubernetes YAML is.
Mm-hmm. Yeah. So basically, your question was what's the point of using basically what's why just stick to Kompose and that's it.
Yes.
Why learn all
yes.
Kedge as well? Basically, the way that we see it is that we hope I don't know if this is being recorded. We hope that Docker Compose eventually kind of dies out.
There is no problem with evolution.
Yeah.
Evolution eventually will sort things out. There's no problem with it. But all the species that are left evolving to the next stage will be suffering from the ones that died out or what.
Yeah. Basically the way we see it is convert everything to Kubernetes, use Kubernetes, but get away from Docker Compose, and then start using Kedge. But we don't know where Kedge is going. We don't even know. We don't even have our first release. And we got some feedback from the community, from Brian Grant and a few other of the core Kubernetes maintainers. And that basically said, good job, but come back to us in a few months when you have a bunch of people using it and you get a bunch of feedback. We don't see Kedge ever fully replacing artifacts. It's just getting people on board to use it, being okay, cool, this is the guestbook app, use it, launch it, learn a little bit of this, but really just move to Kubernetes artifacts, because then we have 3 different standards for launching one thing. Yeah.
So if this is your main agenda to do it, because
yeah.
I think at least you can use the language that Kubernetes already using, but in a lesser amount. So once the developers will understand small footprint of the language, they will be easier for them to move for their full one.
Yeah, exactly. So what you just said is basically having a simple tool like this and migrating people to actually learn Kubernetes. Because to be honest, it's the first time I started learning it is this big massive artifact file. It's really confusing. Under spec, why do we need it under spec? We can just remove that key and have everything under the next key. Yeah.
We have one more question here.
You mentioned stateful sets weren't supported yet, but they're on the way. Do you have a ETA on that?
So basically, funny enough, I'm assigned to that issue, and I'm trying to write code kill 2 birds with 1 stone, write it for Kedge, be able to add it to Kompose right after. But even vice versa, the other way around. ETA, I'm actually working on it this sprint, if anybody's worked Agile. So next 3 weeks, and you'll see something. Yep.
So you said that you're expecting or hoping Kompose to die at some point.
Yeah.
For the average person, developer who's just wanting to cut some code and have a representative environment where they can just edit and reload their page, do you have any suggestions on where they might look for a future-proof solution?
of Kubernetes and Minikube, but even then, like it's a catch-22. It's like, what's the point of using Kubernetes and Minikube when Kubernetes is like hella hard to learn at first, and like when you could just use Docker Compose, and that's where Catch fills in. That's exactly like we saw this niche, and we're like, okay, like all the project managers are like, okay, like please create something here because it's brand new, no one else has thought of it before. But then again, like we don't know where it's going. So, but yeah, there's no other alternatives. You're right. There's Docker Compose, bringing up all your containers, which is great. But yeah, like we'll see from there. Yep.
All right, I think enough for questions.
Yes.
So yeah, I just want to add 2 cents. So there's, we have an incubator project where there's a lot of projects like that, and Kubernetes, and like the hardest part is people heard something and they're trying to use, but they don't know the state. So these talks kind of help all developers to understand current state. We also have a Helm project that was incubator, now graduated. So Helm allows you to, run different sets. Like basically, you can create a chart with, say, chart for the production, chart for, just by modifying the variables, you can, create multiple different versions of the application. There is another tool that is right now in incubator called Draft. So this is Days basically Microsoft, they created this tool so you can Google it and check. So Draft allows you to run, for the developer, connect to the Kubernetes cluster and run your test all the time. Just you modify the code and you can directly test it, so you don't have to do the git commit every time to test your application. So I think we should be good now. Pizza is still on the way, so we decided to have another demo for GKE. You guys okay with that? Okay, cool. So thanks a lot. Really appreciate. All right. So yeah, GKE. I mean, we just talked about Minikube, right? This is like something you can deploy on your laptop. Minikube start, and you're running Kubernetes cluster on your laptop. There's KubeADM that actually you can run in a cloud provider or somewhere like that. And there's like lots of other tools that deploys Kubernetes, but I think a lot of people who are just starting with Kubernetes and want having something production ready, there's nice Kubernetes from the GKE. So we have a quick demo how it works, and then we have a Google representative, Atif, with us. Yeah, you can come and ask questions if you have any. But yeah, it's Kubernetes birthday, so it's in Google, so we decided to have a little bit of Google cloud provider talks about how to run Kubernetes in Google.
Hi guys, can you hear me?
Yes.
Cool. So, hi everyone, I'm Patrick. I'm a customer engineer for Google Cloud working out of the Montreal office. So some of my colleagues from Toronto are with you guys. Since I'm standing between you and pizza, I'll try to make this quick. I don't have a lot of slides and we'll go into the live demo. So I'm here today to talk to you about Google Container Engine. So as Ayrat just said, one of the goals of Google Container Engine is to be the path of least resistance between you and a production grade Kubernetes. There is a lot of ways to deploy Kubernetes. There are some automated ways. There's QADM, there's CloudOps, there's Minikube if you want something local, but a lot of those automated ways of deploying Kubernetes are actually not production ready. So the goal with Google Container Engine is try to get you to start using Kubernetes in an environment that is production grade with as little resistance as possible, so as fast as possible. And we'll try to do this in the demo, so we'll give ourselves about 10-15 minutes, time for the pizza to get there, and we will have a container, Kubernetes cluster running, started from scratch with a pod running in it within those 10-15 minutes. So before I go and do that, let's just start with what is GKE. So GKE is pretty much a managed Kubernetes cluster on Google infrastructure. So what you do when you leverage GKE is that you deploy open source Kubernetes. Actually, Google deploys open source Kubernetes for you, but you are leveraging Google's infrastructure. So As the previous presenter mentioned, Kubernetes actually comes from Google. It is an open source of our internal container orchestrator that's called Borg. So Google does know a lot about deploying and managing Kubernetes. We've been doing this for 18 years now, whereas people in the field have been doing it for maybe 2-3 years. So we have a lot of experience. So using GKE, you're actually leveraging that experience that Google has at managing container clusters in general and Kubernetes more precisely. Another very important point, it's based on open source Kubernetes. So, in contrast to some of our competitors who actually have modified some container orchestrators for their cloud environment, when you are running on GKE, you are running the same version of Kubernetes as everyone else. There's no Googleification here. There's nothing that would prevent you from running the same workload on any other Kubernetes cluster. We support version 1.6 and 1.7. It's a fully managed solution. The other part that's great about running on Google infrastructure is that we can actually automatically scale for as large as you need. And I'll give a small example of what that means in a couple seconds. But one of the biggest issue people run in running their own Kubernetes cluster on bare metal is how fast they are able to scale. So it is very hard to scale a Kubernetes cluster manually. You need to get your hardware, you need to do deployment, there's a lot of operational complexity around scaling, and GKE will allow you to do this, and allow you to do this in a way that's smarter than some of the other deployment in the cloud would be. So there is some features that I will highlight later that will actually make that scaling smarter than just have an auto-scaling group with some instances in it. It's also automatically updated. It now supports automatic repair. So if there is monitoring built in, if any nodes goes down, if any nodes is outdated, we can actually rotate the nodes for you using our intelligent algorithm that I mentioned later. So we're talking about scale. So to give you an idea of what scale you can use GKE in, everyone has heard about Niantic, about Pokemon Go. It was a big thing about last year, so maybe 8-9 months ago. And the way that the people at Niantic and the people internally at Google describes the launch of Pokemon Go is that it is a case study in heart failure for ops people everywhere. And what do we mean by heart failure for ops people? That graph, which has been showed a few times, some of you might have seen that graph already, is very, very, gives a good image of what that means. So that little line at the bottom here actually shows what their launch target was in terms of transactions per second. The red line here was actually the worst case that they had estimated. They had sized for that worst case. And that green or yellow line, sorry, I'm colorblind, so I might be giving colors wrong, but that is the actual traffic that they hit within the first 12 hours of the launch. So what you have is within 12 hours, about 50 times the traffic that they had initially targeted in terms of transaction per second. This kind of scale is great. I mean, anyone who's launching a product would be extremely happy to have 50 times the traffic that they're expecting. It means that it's major success. But you want to make sure you do not fall to death by success. You do not want to be killed because you cannot handle the traffic. Even if you had estimated 5 times as your worst case, you are 50 times over. So this kind of scale is actually something that Google can help you with. So when we're talking about your ability to scale your cluster and to make sure your cluster will be available regardless of the load you will have on it, that's the kind of things that Google will help you with. But that's enough with boring slides and charts. I'm sure that you are way more interested in seeing what that actually means in practice. So I'm telling you, I have maybe 9-10 minutes left in the time that was given me. So let's see what we can do in those 10 minutes to try to get Kubernetes running. Anyone, and sorry, I can't see the room, so I cannot ask who booted up a Kubernetes cluster in the past, but any of you who actually tried to start up Kubernetes from scratch know that it can be a very long and extended amount of work to get to a running cluster. So let's do this. The only thing I did here is actually create a Google Cloud platform project. I don't have anything running in it yet. We'll move into Container Engine, and we will come here and just try to create a container cluster. Actually, I'll take one more minute because I really had done nothing in that environment and Container Engine API was not ready yet. So what's happening right now is that I'm bootstrapping the Google Cloud environment to be able to run containers. I haven't started cluster yet. I need to bootstrap the actual API, tell my project that yes, I will be running some container clusters on that project, and it is initializing the API. That normally takes about 30 seconds. It should be done soon. And once that's done, that will give me access to the API to start and provision that cluster. So I was mentioning open source Kubernetes earlier. There's actually 2 layers of API that we're using in Google Container Engine. There's the Google API that will allow you to manipulate the cluster itself. So that's the API that you will use to start your cluster, scale your cluster, change some features, change some settings. That's the Google API. And once your cluster is started using that API, you will see that we will be using some very standard Kubernetes API calls to make those requests. Since GUI is the most better than command line, I will actually be using the GUI to deploy the container cluster here. You can do the exact same thing that I will be doing with the GUI through either RESTful calls to the API or to the command line. So the ability to actually provision a full cluster in a small amount of time using either API or CLI is actually something that's extremely powerful. And that's powerful because that means that you can actually automate the creation of your clusters. I've seen some use cases for some short-term jobs where container clusters are created on demand. So rather than have a large pool of resources, which might not be fully utilized or which you might not need at all time, there is actually a way to use automation to, through the API, create your clusters on demand, deploy your jobs, and just shut down the cluster when you're done. It provisions fast enough for this to be an option. And since Google actually bills you by the minute rather than by the hour, if you run machines for a small period of time, let's say 10, 15 minutes, you will actually build a lot less than if you add that machine running for a long period of time when it was underutilized. So while I was babbling about those features, my API actually got initialized, so I can go and create a container cluster. So how do I do that? I will give my cluster a name. I will call it Kube Toronto. No description. I will choose where that cluster will run. Okay, I think it was not live demos. It's always the fun thing. Sorry, I'll just reload. My UI was not fully provisioned yet. Okay, cool. So I'll call this Kube Toronto. I can type. We'll choose a zone, so I'll put this in on the East Coast.
Hi, sorry to interrupt. Can you make your screen a little bit bigger?
Yeah.
Can you zoom in a little bit? Thanks.
That's better?
It's amazing.
Cool. So we'll choose 171 as the cluster version. We'll go with the latest version. And here we can actually choose the size of the machines. We can also go with custom machine size. So let's say that I want a machine with 1 CPU, but I want 8 gigabytes of RAM. Sorry, I need more CPUs for that. So 6.5 gigabytes of RAM running on container optimized OS. So what will happen once I click create on that cluster is the Google backend will provision worker nodes of the size that I mentioned here. It will actually do and create 2 of them, and will boot them with an image of an OS that's called Container Optimized OS. Container Optimized OS is a very minimal Linux distribution, really optimized just to run containers. So this is what we will provision on those nodes, and we will install and configure Kubernetes for you on those nodes. Something that you might have noticed, I'm talking about worker nodes here. I'm not talking about master nodes. GKE actually abstracts from you all of the management layers. So the Kubernetes master that you will be connecting to and all of the etcd clusters and everything that goes in the back end is actually provided by Google. So this is not something that you need to size. This is something that will auto scale and that is abstracted from you. So you can actually focus only on your worker nodes, only on the actual resources that will be handling your requests and that will be running your workloads. That's the resources that you care about in the first place. So now that we have two, we will go and turn on some beta because it's a demo, might as well turn on beta. So I can ask my nodes to be automatically upgraded. That's for minor versions. Obviously, if we move a major version, we will not automatically upgrade because that might break things. But automatically upgrade nodes will move between major version, and we will enable automatic node repair. So if monitoring shows that your node is having a hard time, it will actually rotate that node. We will go here and actually make that cluster highly available. As I said, the goal here is to deploy Kubernetes in a production grade manner. If you want production grade, you cannot have only one availability zone use. You need multiple zones. So I will come here and say that I will also run it in US1 East B. So I will be in the same region, all on the East Coast, but I will have 2 hosts in each of the zones. So 4 zones total for 4 vCPUs and 26 gigs of RAM. Right now I'm using Google Containers Engine multi-zone federation. If you wanted to federate that cluster with an on-prem cluster, with a cluster running in another region, in another cloud provider, you can actually add another layer of federation the same way you would federate normal Kubernetes cluster. Again, it's open source cube, yet there's nothing weird going on. It just allows you to create your node pool highly available from the start without having to worry about federation. The rest is not all that interesting. So what I'll do here is actually click create. And now Google is working on deploying my cluster. What happens when Google deploys my cluster? A few things happens. First thing, it is in the backend deploying that master and that management layer we mentioned earlier. So it's provisioning its CD on Borg jobs. So behind the scenes, you don't see those. It's provisioning the master. It's giving you access to that master, creating the rules for role-based access control on that master. It's creating all of the master. In parallel, while it's provisioning that master, that management layer, it's actually also booting your worker nodes. Your worker nodes will be standard VMs, so nothing special, nothing that is out of the ordinary. It's just standard VMs that will be provisioned with container optimized OS and have Kubernetes set up to talk to that management layer that was just provisioned for you. And to show its normal VMs, I could actually come here and just SSH into one of those VMs. And as I SSH into one of those VMs, you'll see I'll have a very standard Linux with all of these standard Kubernetes processes running. It might have been just on this side of having finished to boot. Okay, here it is. So if I come here, you can see that I just have all of it's the standard Linux. It's a container optimized OS, and you have all of your daemons. If I wanted to customize the Kubernetes deployment, if I wanted to drop anything on those VMs, I could. We don't recommend doing it that way. There's other way to automate modifications to Kubernetes, because otherwise you might be losing some features when you autoscale up or down, but this is something that can be done in standard kube. So while those instances are finishing to boot, it will take maybe a few more seconds. We'll go back and look at the status of our cluster. So I'll come here into Container Engine, which was not in my shortcuts. Container Engine right here. And we see that the cluster is still booting. Something that's extremely interesting here is as the cluster boots, as those nodes come up, it actually integrates automatically into Stackdriver monitoring. So I can monitor the resource usage of those VMs. And it integrates with Stackdriver logging. So if I wanted to see the logs on my hosts right now, I could come here into Stackdriver logging and choose not firewall rules, but my cluster, Kube Toronto, and come see in the zone C what's going on. I will see that the cluster is booting. And as I start adding containers, start adding pods into that cluster, I will be able to go and see even the logs of those pods. So all of the pipeline to bring your log to a centralized location is built in, and all of the pipeline to monitor Matrix on your instances is built in. I will not have time because I'm holding you from getting pizza to show you monitoring. But if people are interested in seeing monitoring more in depth, come talk to one of us from Google. We can show you more in depth what you can see in Google Stackdriver monitoring. So why I was showing management, if we go back to, sorry, not compute engine, container engine, we'll see that my clusters is still booting. So we probably need a few more seconds. There's a few hosts being booted. What I'll do, I'll go and, oh, here it is. It's getting almost ready. So I'll start my Cloud Shell, and I will start a shell that will allow me to interact with that cluster. So we'll establish connection with my Cloud Shell. I will clear the tests that I did because it's live demos, but I at least tested it. So what can I do here? I can come and tell my API management that I am the US East 1 C zone. So I will set config set compute region US East 1. I will tell it that my zone is US East 1C. This is the primary zone where I started it. Remember, we have worker nodes in 2 different zones, but it's the main zone. And once this is done, I can actually just tell Google to authenticate me to that container cluster. So container clusters get credentials, and the name of my cluster, which is kube. So what did that do? That actually created a kubeconfig file that allows me to talk to my Kubernetes. So all of the authentication is done through the Google API. You're authenticated using your Google account that I was logged in my shell. And now I can start interacting with my container cluster the same way I would normally. So if I want to go and see my pods, there's no pods, so that's pretty useless. My first one was supposed to be nodes. So if I come and see my nodes, the first call is slightly longer. It requires some exchange of certificates. It requires some authentication, so it might take a few seconds for it to show my nodes. But once I've had that first initial handshake, we'll see that the commands go as fast as I'd expect them to go. So while it's getting my nodes, what can I do with that cluster? So I probably have about 10 seconds left on that. Oh, here it is. I have my 4 nodes. I could come and scale that cluster up or down. I'll actually go and scale the cluster down. Let's say that I add two nodes per zone. I want to go down to 1. I will come here and just save. And Kubernetes will actually, well, Google Container Engine will actually go and scale down my cluster. So it will take a few seconds. It's fast because there's no app running now. If I had app running, it probably would have taken about 1 minute to 2 minutes. The reason for that is when we do scaling operations, especially scaled down operations, there is more intelligence baked into the product than the standard just shut down random hosts. GKE will monitor your host, find the least, the one that are under the least load, and will migrate the pods to other nodes before shutting down the nodes. So there's actually some intelligence. It's not just pulling the plug on some nodes. The migration will happen before you shut down the node. This is why if I had application running, there might have been a slight delay. I will go, and we see that I have 2 nodes that are not ready now because those 2 VMs are shut down. If I give it a few more minutes, they will actually disappear from my cluster. So now I have a cluster running, just 2 nodes, but that's okay for a demo. What can I do? I can come here and create a deployment. So I have a very simple deployment. That deployment is just one Nginx pod. It's actually the deployment from the template on the Kubernetes website. So this is extremely simple deployment. What it's doing now, and I've just been notified that pizza is here, so I'm closing down. Just give me 1 more minute. So if we go and see the pods, I now have my pods running. There's 3 replicas. I actually have 3 pods running. Something else that's interesting, we actually added some layers around the Kubernetes API. So you can come and monitor the workloads and monitor what's running directly in the Google UI and capture this via API also. So if you want to use the Google API to see what's running on your cluster, to get information, I can actually remove this filter to also see all of the default containers are run in system, you see that we have the standard. So we have fluentd for logs, we have Eapster, we have kubedns, there's autoscalers in place. Everything is integrated by default, so you can go into our UI to see what's going on in Kubernetes. One last very important point, GKE also comes with a built-in ingress controller for Google load balancing. So if you want to leverage Google global load balancing, which is a very, very cool tech, it's not what I'm here to talk about, but look at Google's load balancing tech, it's really interesting. You can actually create backends and front ends in Google Load Balancer directly from your ingresses. And this is something that you don't have to add. This is a controller that you do not need to run on your nodes. So it will not require any additional resources. It's built in and it will create load balancing with globally available IP addresses, all of the nice things around Google's load balancing offering. So since Pizza is here, I will not stay between you and Pizza. Any questions, anything? You can also go and see my my colleagues who are on site if you want, if you have any questions.
So we can also ask questions via the mic to Patrick directly. So does anyone have any questions? No? Come on. Okay, hang on.
Thank you, Patrick. How would you recommend DB schema migrations in Kubernetes?
Database in containers are always a complex subject. I would need more information than just that question to answer in depth. Normally, depending on what you're planning to do, I would probably recommend not running the database itself in Kubernetes. If you're running on Google Cloud Platform, there are ways to do this and integrate with some of our other DB products. Normally, just in terms of storage, normally I've had bad experiences with databases in containers.
Sure.
Doesn't mean it can be done, but yeah.
It was more, I've got application version 1, which has a certain database schema, and I'm upgrading to application version 2, which is talking to an external MySQL instance on Cloud SQL or another VM somewhere. How would you go about managing the change between those two schemas?
Understood. Sorry, I had misunderstood your question. This is also something that's challenging. What I would recommend in that case, Kubernetes itself will not solve that problem. So you need something around Kubernetes to help you with that. There's a project that's been open sourced by Lyft and Google a few months ago that's called Istio, I-S-T-I-O, which actually has features to allow you to do that. It has a lot of nice features. It also has service mesh, but something that it allows you to do is to create multiple versions of your application and migrate the traffic from one version of to the other. So what I would probably do is use something like Istio, embed it in the code so you can actually migrate the traffic cleanly from your old version to the new one, rather than try to do a live upgrade of the schema. There's a lot of caveats to that. It's a very simplistic answer to a complex problem, but that's where I'd start. It has features that are similar to what we do in App Engine for multiple versions and service control that way.
Thank you. Anyone else? All right. Thanks so much, Patrick.
No problem. Thank you. Enjoy your pizza.
Thanks.
Thanks.
So we're just going to take a quick 5-minute break. If anyone wants to eat anything, there are cupcakes, but please come back because we do have one more really awesome talk from Mike. I also wanted to mention this meetup is a little bit different from the others because we had a lot of community involvement, and we had Mike and Charlie contributing from the community. So in the past, we've had some sponsors, and while the topics are obviously always really important and relevant, we really encourage people from the community to submit talks. So I will post on the meetup page the link and also in the Slack channel. So if anyone wants to submit a talk, please do so. We really appreciate everyone coming out and proposing talks and issues that they've had at their companies. So with that, let's just take a quick break, and we'll see you in a few minutes. Thanks.
to the people, spread it across the country. Labels out here, now they can't tell me nothing. We give it to the people, spread it across the country.
Here we go back, this is the moment, tonight is the night. We'll fight till it's over, so we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Here we go back, this is the moment, tonight is the night. We'll fight till it's over, so we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us.
Now, can I kick it? Thank you, yeah, I'm so damn grateful. I grew up really wanna go fronts, but that's what you get when Wu-Tang raised you. Y'all can't stop me, go hard like I got an 808 in my heartbeat. And I'm eating at the beat like it gave a little speed to a great white shark on shark week. Raw, time to go off, gone, deuces goodbye. I got a world to see, and my girl, she wanna see Rome. Caesar make you a believer, nah, I never ever did it for a throne. That validation comes from giving it back to the people. Now, sing this song and it goes like, raise those hands, this is our party. We came here to live life like nobody was watching. I got my city right behind me. If I fall, they got me. Learn from that failure, gain humility, and then we keep marching.
Can we go back? This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Go back. This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us.
So we put our hands up. So we put our hands up.
Let's go. And all my people say, that's right. Feels good. And all my people say, talk to 'em, Ray. And all my people say,
Can we go back? This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Go back. This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us.
Could dress up to get love, but guess what? I'm never gonna be that girl who's living in a Barbie world. Could wake up and make up and play dumb, pretending that I need a boy who's gonna treat me like a toy. I know the other girlies wanna wear expensive things like diamond rings, but I don't wanna be the puppet that you're playing on a string. This queen don't need a king. Oh, I don't know what you've been told, but this guy right here's gonna rule the world. Yeah, that is where I'm gonna be, because I wanna be. No, I don't wanna sit still, look pretty. You get up on it 9 to 5, dream of picket fences and trophy wives, but no, I'm never gonna be, cause I don't wanna be. No, I don't wanna sit still, look pretty. Mr. Right could be nice for one night, but then he wanna take control, and I would rather fly solo. The Snow White, she did right in her life, had 7 men to do the chores, cause that's not what a lady's for. The only thing a boy's gonna give a girl for free is captivity, and I might love me some vanilla, but I'm not that sugar sweet. Call me HBIC. Oh, I don't know what you've been told, but this guy right here's gonna rule the world. Yeah, that is where I'm gonna be, because I wanna be. No, I don't wanna sit still, look pretty. You get up on it 9 to 5, dream of picket fences and trophy wives, but no, I'm never gonna be, cause I don't wanna be. No, I don't wanna sit still, look pretty. Sure, I'm a pretty girl up in a pretty world, but they say pretty hurts, and I don't wanna sit still. I'm The night was warm, we were bold and young. All around, the wind blows, we would only hold on to let go. Focus, fire gun, we need someone to lean on. Focus, fire gun, all we need is somebody to lean on. Focus, fire gun, we need someone to lean on. Focus, fire gun, all we need is somebody to lean on.
Hey, everybody. We're going to start again. Hey, Mike. Hi. Nope. Everybody eating cupcakes, come back in here. Bring the cupcakes in here. It's okay. Are they good? Did anyone? What's the story on the? They're good. Okay, awesome. Yeah, lots of icing on there. Okay, cool. So I'm gonna hand it off to Mike, and yeah, thanks, Mike.
Thanks. Can everyone hear me? Alrighty. Let's give people a second. So my name is Michael Wojcikiewicz. I'm a senior engineer at Kash Corp. We are a fintech company. Small startup run out of Toronto mostly, and also in San Francisco. I'll be talking about our experience moving to Kubernetes in the last year. So we went to production last year, about exactly a year ago, and so kind of hurdles, learning, growing pains, things like that we came across as we moved along the way. Quick intro on myself. We'll talk about some patterns we use when we move to containerization, some of our philosophies we keep in mind when we design new solutions, various problems with Kubernetes we encountered along the way, some information on how we do monitoring, and a lot of best practices and things to avoid, specifically on the Google Container Engine platform. A lot of the stuff you actually just saw the guy do, I would recommend against, and I'll get to a lot of that stuff as I get through it. We're very advanced usage, and some of the stuff will just trip you up along the way. And hopefully we'll have some time for questions and answer at the end. We'll get to that. All right, so I'm going my 20th year of professional development. My PowerPoint skills are very poor, as you can see. I don't have fancy animations, things like that. I'm a veteran of the first .com boom and bust. Used to do Perl, a lot of Perl. These days we're mostly Node.js. I spent 10 years at Morgan Stanley, a big US bank in New York, 5 years as vice president. And we worked there's a huge infrastructure working for a company. Then we had about 100,000 servers around the world, all different kinds of versions of OSs. Very, very interesting to work in that kind of environment. They're a Linux shop, open sourced. So I learned a lot of things for distributed design, distributed systems that I take into my everyday where I'm working now, which is at Kash Corp. So as I mentioned, we're a small startup focusing on the American market. We're about 9 engineers, actually. I recounted earlier today, and about 3 or 4 salespeople, mostly in San Francisco. So when I started at Kash about a year ago, about a year and a half ago now, they were running a traditional 3-tier design, presentation layer, business logic layer, database layer. Our deployment was on, we've been using Google Compute Engine since the beginning. So we're totally, by the way, I just want to do a quick disclaimer. So I'm going to say a couple of things that are probably going to be not so nice to some Google features, but I'm doing it out of love because we love Google. We just want things to get better. I just want to highlight them. I figured this is a good forum as any to do that. So yeah, so when I started, we were running everything on VMs. So we had 2 app servers, A and B, proxy servers serving as front-end content, database server master slave configurations. It's Postgres, and we were on Compute Engine. We also have some complexity that's maybe not standard to other deployments. Since we're dealing with financial data, we have kind of a production environment that all our developers can access, and we have a secret environment that very few entitled people can do, and that's where all the sensitive data is stored. So that adds a lot of complexity as well for our Kubernetes setup, since we can't just run everything in a single cluster. Things like RBAC that came out recently, we haven't played with it, but that holds promise for us to kind of solve that problem in the long term. So our development environment is based on Docker and Docker Compose. It's pretty much exactly the way that my colleague described it earlier. We're using Docker Compose to bring up a full development stack with all our databases, all our various components, microservices, and run it that way. So we're using custom Docker images. So this is kind of a pro tip as well. If you're using, if you care at all about like consistency in production, definitely pin all your images, and better yet, when using images that aren't owned by yourself, do like a quick fork of them and maintain them yourself. Don't rely on upstream things. People can change, people can insert rootkits, all sorts of things. So definitely take control of all your own images. So we did that for ourselves. We built our core image based on Alpine Linux. So Alpine Linux is a small distribution. I think it's about 120 megs for like a fairly well-tooled distribution. And then we build Node.js on top of that, and that ships as our base image for everything, which then bundles our source code on top of that as well. With our Docker Compose setup, all the configuration options we have for our application are defined in environment variables. So that's just kind of how we started, and it seemed to be an easy way for us to change configurations on the fly. We haven't taken the Minikube dive yet. Last time I looked at it was just about a year ago, maybe a little less. There's a lot of features missing, which we needed. Things around services, things around disks, which I suppose have improved, but I don't know yet. So for the time being, we're probably going to stick with Docker Compose. I wasn't aware there's so much development on newer versions. All I got to say is we use version 2.1. It's been working very well for us for a while. And it maps, conceptually, it maps very nicely on top of Kubernetes as well. Obviously, there's not a lot of features, but when you're developing features in your application stack, you don't necessarily care about the Kubernetes-specific stuff. It's more of a DevOps type thing. So just a quick note on my distributed design philosophy, and this is heavily inspired by Apache Cassandra. The reason why I just want to bring this up is that it goes into, I keep this in mind whenever I design new solutions, and especially with Kubernetes, how to best take our legacy application and put it into Kubernetes, and what extra steps we need to do. So as I said, this is based on Apache Cassandra design philosophy, which I think is one of the model applications for a distributed design. There's no master slave, there's no single point of failure. It's a very, very well engineered application, multi-region, massively redundant. So I keep those kind of philosophies in mind when I design when I put things into Kubernetes. So specifically around no single points of failure, to be massively redundant or have lots of replicas running in itself, to be multi-region, so you can survive zone outages, which expect them to happen at least once a year. It's happened in Amazon and Google, I think, in the last year. So don't hope it doesn't. And don't assume multi-zone is enough. You definitely, no, sorry, multi-zone, you want to go multi-region. There's a concept called Chaos Monkey, which I'll talk a little bit about later, but not too much because I think I'm running low on time. But it's basically assuming that failures are going to happen in your application, and you're better off coding your application to be resilient for these types of failures. So Chaos Monkey is a thing that runs in a distributed environment and randomly brings down things to make sure that you can recover from them gracefully. Having rolling restarts, meaning less downtime when you do application upgrades. And very important as well is having a single source of configuration truth, so you don't end up juggling, configuration management database, configuration files, all these kind of places. You really want to be careful about where you store your configuration data. And that's a great way to achieve high availability. So for us, it was easy to start moving towards Kubernetes. Essentially, since we're all running everything in Docker Compose, we literally started with using the images that we had created for Docker Compose. And then we started refactoring some of the work. Our application stack is Node.js, and we had essentially a Node.js file for every project, which would contain all the configuration options for that project. So we started basically refactoring those into being able to work both as a Node.js file that we could use in our applications, but also to be able to specify these configurations in environment variables. And the way we do that is by using config maps from Kubernetes and secrets from Kubernetes. I'll talk a little bit about secret problems in a few slides, because secrets are things you want to stay secrets, but if you start putting secrets into source code control and other places, they're not secrets any longer. So first bit of work was basically separating out all the configuration data, and then we create deployments, Kubernetes deployments for each of our components, which maps the config maps and the secrets into environment variables for our application to pick up. And I'll talk a little bit about how a component we built to make that easier as well in a couple of slides. One other thing we started to realize initially, we had talked about what version of your application do you want to run in your environment? Do you want like a specific 1.1.2? Do you want something that has the commit ID in it, or do you want something else? Through a couple of, we tried each approach for a little bit, but we ended up settling on basically using a single name tag for each environment. So you have a test environment, you have a test tag that you tag all your images. If you have a QA one, you tag it QA. If you have prod, you tag it prod. And each of those images individually then become promoted to each environment. So whenever we land, I'll talk a little bit about our build pipeline as well, but we found that was the best way to kind of separate various environments. Configuration was just to tag them with the name that they're running in. So similarly, as we have specific tags for each environment, we also have all the configuration config maps separated per environment. You had a question? No, never. In our build pipeline, it may pull in latest versions of other images other than the one that we're building, but we never rely on latest. And that's kind of what I was talking to about before, is always pin your versions to exact versions of things that you're running. Never allow upgrades you don't expect, because eventually someone's going to upgrade it, you're not going to know that it upgraded, and you're going to spend a whole day searching for a bug that doesn't exist, right?
So when you're trying to rationalize version that you just updated in prod, do you use the comparison to the original image hash to be able to go, okay, yes, those are all the new prod tag, or?
Yeah, so part of our continuous deployment pipeline, we don't do automatic deploys to production. I'll talk a little bit in a couple of slides, so maybe I'll just hold on for that for now. Yeah, so now that we kind of did the basic refactoring of separating all the configurations, config maps, and secrets, we realized that we really needed a configuration loader for our Node.js applications to make it easy for us to take values from the environment, map them into our configuration inside Node.js, which could be a deep structure, by the way. It's not just foo equals bar. It could be multi-level structure of here's your database configuration, here's a host configuration, here's some options. Those could all be modeled as environment variables and could all be modeled as complex structures inside Node.js. So we created a configuration loader library to kind of help us to do that. We also created some tooling around to make it easy for developers when they need to add a configuration. Like if you need to add you have some new database attribute you want to add, rather than having to go into 10 different YAML files and update them and find where they are and having typos, things like that, we created some tooling around that to auto-generate our deployment YAML and our config map and secret YAML from what the application thinks it is. So the developer just goes in and adds a new item for their configuration, they run our tools, and it'll just update all the YAML for us. So when they land a code review for a feature that they're doing, we see the full context of what it is they're doing, exactly which variables are added, which ones are removed, which secrets are added, how they're mapped into the configuration, how they're mapped into the application. Everything is kind of bundled into one, or a series of dependent code reviews. No, none of it's unfortunately open source. I'll talk a little bit about why it's not in just a minute. Yeah, and so we also, our ops tooling also keeps a track of all our Google container clusters, right? So we have for each environment, we may have multiple clusters in each environment. We have just one single source of truth for that, so all our tooling can use that. When I say, restart this application in prod, or apply this configuration in test, it'll know what you're talking about just based on that. You don't have to remember cluster names and all this kind of stuff. One other thing we had to do is to really take full advantage of what Kubernetes offers in terms of rolling restarts is to implement the SIG-term handler, right? So when a Kubernetes pod is shut down or basically to bring up a new version, calls SIG-term on your pod, and if you don't implement that, you can just wait and kill it. But if you implement that, you can allow, if you're in the middle of a transaction or you're doing some work, to just finish that work before you actually release the handler, and then the pod shuts down. This can add some time for rolling restarts, but it makes them much less error-prone. Every deployment in Kubernetes has a concept of liveness checks and health and readiness checks. So these are health checks and, hang on, am I not looking at the right thing here? Okay, sorry, I got confused. Sorry. All right, so our stack, every component that we have that's a microservice is based on a framework, and that framework has an implementation for a health check and for a liveness check. So health check would be something like, if not only is my application up and running, can it talk to the database that it's talking to? So it just does like a select now from database and returns true. Liveness check is something responding on the port. That's just, we just have a basic like return the timestamp of when you're doing the call, right? So the difference here is like if the pod comes under heavy load, let's say you're running 10 pods in a deployment, 10 replicas in a deployment. If 2 or 3 of them are servicing requests, they can actually remove themselves from the health check, from the ready pool of pods by reporting themselves as unhealthy, right? So what Kubernetes then will do is it'll just route the traffic to one of the other pods. We're going to talk a little bit at the very end of the talk about what the next steps towards doing that is, because what we're finding is the Kubernetes service layer that manages which pod receives which traffic when you're dealing with multiple replica deployments, it's not as responsive and as reliable as you'd like it to be, especially depending on your state of your nodes and things like that. But I'll talk a little bit about that later. So I talked about storing the configurations.
Just quick question.
Yes.
For resource and limitation, do you use any how you find out what is the best?
Sorry, for what?
Resource and limitation.
So I have a talk on monitoring, and we basically just collect a lot of metrics, and we try to figure out what's using the most and manually balance our workloads. Right. So the reason why a lot of the things I've talked about I don't want to realize is because they were written over the span of about a month last year, and they're written mostly in Bash, which is so they're basically symbol wrappers over what Kubernetes already provides. So you have these kind of verbs: create, update, apply, replace, delete. We basically wrote like a wrapper that models each of our applications and then dependencies in a simple shell script. So for example, our main entry point for our API is defined as a single deployment that has maybe 10 replicas for the production environment, 2 or 3 services, one service to define its traffic internally in Kubernetes, and one service to define the ingress from outside of Kubernetes, and I forget what the third service is for. And then maybe one config map, one secret, and optionally a migration job. So our tooling will then say, okay, if you have all these 5 different things, which I kind of realize Helm is supposed to do, but I'll talk a little bit about Helm in a little bit. Basically, what it allows us to do is very quickly create a new, when we want to deploy a new component, we just point which YAML files we're using for that particular deployment, and all the tooling that we built around it just works with it. So for example, when you want to deploy something to production, there's always a certain order you want to do it, right? First, you want to put in your new config maps and secrets rather than after, because it requires restarting the deployment in order to pick up the new secrets, the new configuration. Then you want to apply your services. Then you want to create and delete migration jobs. So the reason I say create and delete is because migration jobs, when they run to completion, they don't remove themselves. That's to inspect the results, I think. It makes it a bit of a pain because next time you run it, you either have to create a migration job with a new name, or you just delete the old one, which is what we do for now. So migration job is something like you added a new database table, or you added a new database column, or something like that, or you have to run some sort of series of web requests. It's just basically a job you run once rather than running, it's a deployment you run once rather than running continually. And then finally, once you've done all of that, you replace your application deployment. So you may notice I'm using a couple different verbs here, replace and apply. Replace will do complete in-place replacement of all the configuration items you're defining and removing anything that was left over from the old one. That's the difference with apply. Apply will just take the sets of what's running with the sets of the new things that you're adding, and then the end result is both of them together, which is maybe not what you want if you're replacing environment variables or replacing configuration items. You don't want to keep old data lying around. So because this order is very specific and we can use it for all our tooling, essentially all the bash stuff that I wrote just kind of does that behind the scenes, and all the developer really does when they create a new component is just a few small declarative statements saying what YAML they're using, and everything else is handled for them. We're looking at probably rewriting this stuff in Node.js as well, using the Kubernetes APIs that have since become available, but at the time that wasn't really much of an option. And the last thing it does is it validates end states. So that's after you've deployed your application, do you have the desired number of copies running that you've specified, and was there any errors or things like that? If there's any errors, we don't have automatic rollback yet, but fortunately, if Kubernetes deployments if they fail to start, like if you put in a new version of your application, if it fails to start, it'll just Kubernetes will just eventually stop it and keep the old version still running. There's some obvious issues here if you've done configuration updates that affect the new version, but this works like 80–90% of the time for us, so that's a really good point, really good for us.
Sorry, just want to add, because there are several interesting projects right now in Kubernetes that are not official yet, but also in an incubator. So because we don't have access to your tooling, there is a project called App Controller that allows you to create sequencing order. Like you want to first deploy secrets, configs, then database, then So App Controller is kind of replacing your bash scripts if you want to check it as well.
Yeah, I'm very curious about what's out there. Realistically, we're such a small shop and we have a lot of work we want to focus on just doing for our application features, but I'd like to take a look at a lot of the infrastructure work as well. And so I might hit you up on Slack actually for those recommendations, because unless I write them down, I'm not.
And also the Helm project as well, if you want to use Helm, you can actually implement, let's say, a check, like a job or init container. It's called init container that you can check, is my database is up? If yes, let me deploy the next application on top of it. So that's another way to implement sequencing.
Yeah, so I think I'm actually going to get to this soon. With respect to, in a couple slides. Helm I found, which I started playing with about 6 months ago, and I was extremely disappointed by none of the tutorials worked. Everything it was saying was supposed to work, it didn't work, and I had no idea what to do, and I just kind of gave up. Maybe it's come a long way since then, but at the time it just wasn't an option for us. Right. So secrets. Now, obvious problem here is how do you store passwords? How do you store private key certificates in your configuration? Right now, everything I've been talking about has been in our company-wide Git repository, right? But we have a policy we don't store secrets in our Git repository. So how do we deal with that without we still get the benefit of being able to use Kubernetes secrets without a lot of overhead in managing them? So we really came up with a very simple solution. My colleague Jeff over there just kind of blurted out one day. Is Google, another feature that Google Cloud offers is called storage buckets. And there's a command line utility that allows you to access them. So what they are is they're per project specific. You can just store whatever files you want there. You can tweak entitlements to who has access to them, which is our main things. We only wanted our developers to have access to the public-facing stuff, and only our CTO and VP of engineering to have access to our financial data secrets. So this actually allows us to do that. So what we end up storing in our code repository, instead of putting the actual contents of the YAML, we just create a special file that's essentially a symlink to the YAML. So you can see an example there. It goes to my bucket, the component, some SHA. Does this work? No. Yeah. So we created another verb for our tooling, which is very simple to do because it's all bash and everything is called edit secrets, which all it does is it grabs the file from gsutil, puts it through a base64 decode, which is how you store your secrets in Kubernetes, and then just puts the file into the user's editor, which your Emacs or VI or whatever. And then when you save it, it does the reverse procedure, puts it back, and you don't really have to think about it. That was always kind of a hassle, especially initially before we had this, was editing the secrets. You always have to do the base64 decode and encode. It's not easy to see what it is you're doing. With this method, it works. Of course, the only problem is if you're putting binary data into there, that's not going to play so nicely with your editor, but fortunately, we haven't had that problem yet. Okay, the database problem. So the Google guy said before he doesn't recommend putting databases into Kubernetes, and we've done it. Now, I'll talk a little bit about the struggles we had and things like that and limitations, but it's possible to do, and ideally, over time, we really want to have everything running in Kubernetes, not having to deal with like security updates and things like that, managing hardware, all the overhead with that. We just don't want to have to worry about it. And by the way, I just want to say we don't have any dedicated database engineers. We don't have any dedicated database administrators. We don't have any dedicated system administrators. We're a small team where everyone kind of does everything. We have some specialization, but this really allows us to not have to worry about having someone who knows how to run the database and things like that. So in an ideal world, we'd all be running Apache Cassandra, which is my favorite distributed database, but really you can insert your favorite distributed system here. But reality means that we really have to deal with what we have and where we'd like to go, possibly at the same time. So right now we have a lot of legacy, most of our code is using PostgreSQL, running in a standard kind of, used to run in a separate VM. And new code can be running in Cassandra, where we have kind of a multi-region redundant Cassandra install. So whenever we do kind of upgrades of our environment, we never have to worry about Cassandra, which is great, but we always tend to have to worry about Kubernetes a little bit. And I'll talk about those problems in a couple slides as well. So yeah, Cassandra is easy, right? It already exists in multiple data centers. It already has these kind of replication features. It means we can actually survive 2 nodes going down at the same time, but still have read and write service to the cluster. Postgres is a lot harder. Initially we had master-slave replication set up, but it still requires you to kind of do a manual action to force a failover from your master to your slave. There's probably complicated systems out there that maybe make this better, but in the end, due to the limited resources we had, that was kind of the only solution we could come up with. So once you execute the failover, essentially like a new master, you have to reroute all the traffic to the new master. So that also means you have to tell your code where the new master is. So this was, thankfully, we never actually had a situation where we had an outage related to this, but it was a problem that was just waiting to happen, and it could cause outage of several hours depending on who's available to kind of deal with it or not. There's also a hassle to have a separate infrastructure of VMs to manage, and they can't really share resources with anything else either. So we discovered this project called Stolon about 6-8 months ago. It's written in Go. It's made for Kubernetes. It basically sits around Postgres and provides a lot of high availability features that you don't have to worry about. So it utilizes the built-in streaming replications to basically allow you to define, say, okay, I want to have 1 master and 3 slaves. You just put that in your YAML, and it just manages it for you. Because it runs inside Kubernetes, sorry, hang on. Lost my train of thought for a second. Okay, right. It utilizes streaming replication so I have multiple hot copies running on standby. It also allows you to quickly kind of pull the switch. You don't actually have to pull the switch yourself. The system will actually monitor the health of Postgres, and will say, okay, now this master is unhealthy. I'm going to switch over to this other master. And you connect through a component that handles sending your data to from one master to the other master. It stores all its data in distributed columns, in a distributed key value store called etcd or console. So I think underneath the hood of Kubernetes, how it maintains states inside a Kubernetes cluster is also through etcd. Unfortunately, this is not made publicly available to you in your cluster, so you need to run another installation of etcd on top of your cluster to actually make this work. And I think before someone asked about if anybody was running operators in Kubernetes. We've been running the etcd operator. It's a separate project from etcd, which manages running your pods inside of etcd inside your cluster, because it's a bit of a pain to run yourself. We actually found it's a bit of an anti-pattern with respect to Stolon, because there's built-in backup features that you don't really necessarily want to make use of in etcd operator. So you're better off just running a daemon set or a stateful set of those, which is an approach we're going to take soon. It can do point-in-time recovery. It can actually have a standby cluster, replicate to a standby cluster in a different Kubernetes cluster, which is our desirable end result. So that even if you have multi-region replication, so even if you lose an entire region in Google Cloud, we can still instantly switch over to the next region. All our services will be running in both. With Cassandra, that's not an issue because it's already distributed, but with Postgres, that kind of provides that ability. I'm just going to kind of race through this. So yeah, it's a couple of components in Stolon. Keeper manages Postgres itself. The Sentinel elects master when it's needed, and the proxy provides the entry point into Postgres itself. So your client's code talks to the proxy, and if the proxy detects a failover, it just points all your connections to the new one. Your application doesn't even have to know about it. And here I talk about the stateful set, daemon set stuff. Persistent disks, not much to say about those. They're great, especially all the dynamic allocation, but there's some issues you need to watch out for. It's really hard to track the usage of the persistent disk, like how much actually being used in a disk. And there's not really any built-in monitoring in Google Cloud for these that we could found. I'll talk a bit more about that later. Continuous integration and continuous deployment. Just want to do a quick kind of preamble for that. Testing is extremely important. If you don't have a huge unit test and integrated test suite in your application stack, you're severely lacking in confidence when you deploy new code. So because we've invested a lot of time in writing unit tests, integrated tests, and even end-to-end tests where we orchestrate a Chromium build to use our application as if a real user was using it, we can actually use this as part of our continuous deployment pipeline to be able to very faithfully and accurately deploy our code to our various environments. So all the tooling that I wrote essentially can now be leveraged using Jenkins to actually automatically deploy. So our build pipeline does a couple of things when anyone lands a new commit. First, it builds a new candidate image with a specific commit SHA as a tag. It runs through our unit and integrated test suite as the developer should have done before they submitted. It runs the end-test locally before it actually puts that image into our new environment, and then it deploys to our test environment using the tooling I had referenced before, and it runs another end-to-end test. If all that succeeds, it reports the results back to Slack, and it gives the developer a command that they can run by themselves to finish the deployment to production. The reason we don't do the automated production deployment is we'd just like to be a little bit extra safe. We like the developer to be aware of when that actually happens. But it allows us to very rapidly develop features and push them out. And, we have several deployments of all our components daily to production because of this. Monitoring. I'm running low on time, so I'm going to try and get through on these. We use Prometheus. It's been mentioned a couple times before. It's really great. It hooks into a lot of native Kubernetes metrics, and you can federate them from multiple environments into a single Prometheus environment, and then you can also create alerts depending on those. So if you say, I have a certain number of 500 codes in my application, you can create an alert, all those kinds of things, right? It's also a lot more complex than that. You can create standard deviations of traffic and all that. And we use PagerDuty for our incident management. So anything that generates an alert inside Prometheus ends up in PagerDuty, and whoever's on PagerDuty that week takes the incident. As great as Prometheus is, it does lack a couple of things. It only collects information that's available to it. So there's a lot of information that we want to look at that Kubernetes doesn't really expose. Important things are basically events in Kubernetes. So whenever a pod restarts, a pod errors out, a pod has an eviction due to low resources. If a node has an event, say like a node fills up on disk, or a node has excessive inodes, or all these kind of things. These are things that happen inside Kubernetes, but you don't have visibility to you don't have the visibility natively. I mentioned before the disk usage of persistent volume claims. So if you have a stateful set that has a database that has a persistent volume claim for the database, you really want to know how much space you're using on that database claim. And one thing that Prometheus doesn't provide natively either is inode monitoring on your actual Kubernetes nodes. So this is a consistent problem we've had. We deploy a lot of images very frequent to our environment. About once a month, one of our nodes has some excess inode thing on it that we have to go in and run some Docker commands to clear out. But we spend a lot of time trying to figure out what the hell went wrong before we realized that was an issue. So what we ended up doing is we wrote some small agents that actually do a lot of these tasks by themselves. They're like 20, 30 line Node.js scripts. Basically just talk to the Kubernetes API using watch. Like, I don't know if you guys have run kubectl with -w. You can actually watch things as they happen rather than just getting a snapshot. So this way, we actually have agents that constantly watch the state of pods, the state of nodes, the size of disks, and they report those as metrics into Prometheus. So we have a dashboard that says, when we can see like a high spike in some error codes combined with a lot of state changes in one of our components, we know that those two events are correlated because if someone deployed something, odds are some things are going to start going wrong, right? So you can it helps you give you a lot more intelligence into how you're monitoring, how you're operating your cluster that way. One other component we developed was a disk snapshotter. So since Stolon runs exclusively inside Postgres or inside Kubernetes, and we use persistent disk for that, we also want to make sure we keep copies of those persistent disks around. So we have a snapshot that runs daily, keeps 30 days worth in production, I think keeps 7 days in test. It allows us to, if we discover some horrible disaster went wrong, we need to recover to a point in time, we have snapshots for that. There's a term called exporter in Kubernetes world, where if an exporter is basically something that gives you metrics somewhere, generally to Prometheus. So people have written some exporters out there to expose the node level metrics. So that's what the node exporter is. That's a very good thing to install on your nodes. It installs as a daemon set. And the Postgres exporter, if you have Postgres databases, will look at Postgres engine metrics and report those into Prometheus as well. I forget what we end up using for JVM metrics, but we also export Cassandra metrics as well. You definitely want to keep if you're using Cassandra in production, you want to keep there's a lot of key metrics you want to keep an eye Okay, so a lot of the value I was going to give in this presentation was actually a lot of the best practices and things we've learned over the last year or so. So generally, I want to say these are just my experiences. They're not written in gold or set in stone anywhere, but this has been what has worked for us since the beginning. So avoid bleeding edge, right? So you had the question about who's running 1.7, and I'm glad to see there aren't many more people because you're out of your mind if you're running 1.7 in production now, or you're very risky. Generally, I found when a new version comes out, we generally don't even start looking at it in testing until it's hit about version 0.4. If you look at change logs for each version and known issues and things like that, you can see there's a lot of stuff that gets ironed out. Essentially, if you sign up for a release when 0.0, 0.1 comes out, you're the beta tester, right? And you don't want to do that in production. Make sure that when you do try a new production, a new version, before it goes to production, make sure you try it fully baked in your development environment or non-production environment. This should probably take a couple of weeks ideally, but at least a week running in non-production. You also want to make sure you retest all your rolling upgrade procedures for production. So for example, we went from 1.5 to 1.6 recently, and the pod affinity stuff that I had asked about before, it used to be an annotation in your YAML with a little bit of JSON in a string, and it changed into a fully declarative YAML keywords, but it wasn't at all. You could do the same things, but you had to describe it very differently, right? So we ended up having to, first of all, we discovered this the hard way. Then all of a sudden, when we upgraded, nothing is running where it's supposed to be running. We discovered, okay, this feature had completely changed, but it also made necessary that when we actually put 1.6 in production, we had to change our normal deployment procedure because we had to deal with this in-between state of being at 1.5, 1.6 at the same time, and having two different annotations, declarations for the same thing that would work differently depending on which node it runs on. Somebody asked about database migration. Our general approach to that is we don't try to overcomplicate it. We have one database at most per component. We use a module for Node called DB Migrate, which allows you to ship along with your feature work, basically a set of statements that allow you to also patch your database, right? So there's a statements for actually putting in the column that you're adding and there's statements for removing in case you have to roll back. This has worked really well for us as long as we take the approach where if we need to add like a feature that requires a new column, we don't ever rename an existing column, right? The reason for this is if you have a new deployment that relies on the column working this way and you have the old version replying the column working this way, if something goes wrong, they get stuck, you get kind of in between scenario. So you always want to make sure as often as you can, if you need to make modifications, do adds, deprecations, and removes. Don't ever just change. So this could mean that by the time, if you want to add a column and remove a column, it could take over 3 releases to do it, but it's a much safer way to do it. As well, don't ever run in a single cluster. I've seen some people talk about namespace separation for prod and QA and things like that. Very, very bad idea, especially since when you upgrade a cluster, you don't know what's going to happen. There's many features that get added or removed. I talk about the node affinity that you're not going to know until you've actually put it in place. So don't keep your prod and non-prod data on a single cluster. I hope I didn't really have to say that, but I just want to be sure. Yeah, so here's some criticisms and some best practices I've learned along the way, and a lot of them are very specific to Google Container Engine. So there's a feature called node labels, which allows you to designate a specific node in your cluster to contain certain workloads. So this is kind of what I was talking about with node affinity before. Problem with this is you can create a node label, but you can put it on a node. But next time you upgrade that cluster and that node, logically to you that node will have the same name, so it'll be called foo cluster XYZ. After you upgrade it, still be called foo cluster XYZ, but your shit will be gone. There will be no node labels. There will be no nothing. And we filed a request with Google support for this, and they came back to us saying, well, this is a feature, not a bug. And I'm like, don't care. It just doesn't work, and it makes it useless. Essentially was that behind the hood, behind the scenes, the VM gets decommissioned and replaced with another VM that has the same one. So it's not the same in that sense, but it is logically the same because it has the same name. So don't do that until they fix it. Don't use alpha features if you can avoid. Definitely not in production. Sometimes you'll be tempted to, but there's some costs associated with that. One is you have to designate your cluster as being alpha, which has to be renewed every 30 days. But really, oftentimes, as would happen with the node affinity I was talking about, they can change significantly when time they come out of alpha or even beta. You just got to be very, very wary of that. IP persistence is another problem that's very Google Container Engine specific. If for whatever reason you use node port services to talk between two clusters or whatever your use case is, you want to know what the node port IP is. The IP is generally the external IP of your VM. So you can reserve your IP address, you can assign it to the VM, but when you upgrade that VM to the next version of Kubernetes, Kubernetes just assigns it a new IP, and better yet, you're not allowed to put the old IP back until it's done upgrading all your nodes. So if you're upgrading like 4-node cluster, 8-node cluster, it could take half an hour, 45 minutes. Those 45 minutes, you can't assign IPs back to that cluster. So huge pain in the ass. And then, of course, if you have to assign them back internally, so there's external IPs for that. Internally, it just gives you a new internal IP. That you can't even assign either. So you very often, after you execute an upgrade procedure, you have to also go and upgrade your config maps again afterwards. So in order for us, our lesson learned best practices upgrade procedure is generally this now. Since the master gets upgraded automatically, which by the way I'd love to be able to opt out of because I don't trust automatic upgrades, it doesn't automatically upgrade your node pools. I would also say don't ever put up the automatic update of your node pools either, because if you don't, you're just going to be spending days hunting things that broke for even no apparent reason until you realize it was upgraded without your knowledge. But our approach then is to basically, when we upgrade, we're anticipating going from 1.6 to 1.7. Our master is probably already 1.7, so rather than doing a rolling upgrade on our existing pool, we're going to create another pool with the exact same specs running the newer version, change our pod affinities to point to the new version, and manually fail over each component to the new version, and then decommission the old node pool. There should be something that the tooling could do by itself, but it doesn't, and for all the reasons I've already talked about. Don't trust managed infrastructure. So a lot of what this guy's talking about is all great and good if you're running in a very kind of simple application and simple structure, but it doesn't really translate well to reality. So really, always validate and monitor what you think is happening. Watch out for little quirks, like I'm talking about the node pools, causing the IPs to become unavailable for the duration of the upgrade. There's something else I wanted to add here. Oh yeah, talk about it in a second. One of the examples uses Redis in Kubernetes. We found Redis in Kubernetes is extremely unstable, especially like any kind of serious prod deployment. We're about 50% chance whether we have an outage with Redis when we do an upgrade or not. This is something that may have been fixed in version 5, which I think came out recently, but we're not sure. So just be wary of that. I talked about Helm, had tried it out. Might give it another try now if everyone's talking about it. Ingress at Google Cloud, this is another very Google Container Engine specific thing. It can be difficult as well. There's some built-in limitations to how Google will model your Kubernetes cluster and deployment versus what it actually exists as in Google Cloud terminology. So the guy showed, when you create a 4-node cluster, there's 4 VMs that are automatically created associated with that. Those VMs are also created in what's called an instance group. So every time, like for example, you create a service in Kubernetes that's fronted by something, Google will create a load balancer and put that instance group in that load balancer, right? That's great for when Google manages that. For another reason, one reason or the other, we couldn't use the built-in Kubernetes load balancing features, so we had to create a separate global load balancer in Google Cloud. And then we would assign our instance group representing our applications in Kubernetes to it. But what we ended up finding was if we wanted to have, say, for example, multi-region deployments where we'd have one Kubernetes clusters and group in one region, another Kubernetes cluster group in another region, we couldn't put both groups on the same load balancer. Even though it should be able to, you can only have one group associated with it. And inversely, these are just little things that you expect to work, but like there's no reason why it doesn't work, and there's no explanation given. They don't support it yet. I found that happens a lot with Google stuff. It's like it works for them, and they don't have a concept of what your use case is, so they don't code for it. Yeah. VPN tunnels at Google can also be very difficult. So recently, I think it's about 4 months ago now, we had a 15-minute VPN outage. So I talked about our cluster supporting having our developer public one and our financial data private cluster. They're connected with a VPN tunnel. So we had a 15-minute outage recently, which, if you can imagine you're a financial tech company, someone like PayPal taking payments. If you can't do payments for 15 minutes, it's a pretty big outage. It's a lot of money involved. There was no notification for Google this was happening. This wasn't put up on the incidents board. This wasn't like even reported. So we filed a request, and the support person came back to us and said, oh yeah, this was down. And since we're still meeting our 99.7% SLA, we didn't have to report it. That's 30 minutes in a week that your shit can be down and they don't have to tell you. That's a little bit unacceptable if you ask me. We also, because we suspected this was the root cause behind a couple of recent failures that we had, we requested logs of previous failures, but it was just ignored and we just gave up. So we weren't ever able to satisfactorily find a root cause for those. So the lesson to that is always monitor your managed infrastructure and try to have multiple redundant versions of the same type of infrastructure. So in this case, the Google support guy came back to us and said, well, you should have had multiple VPN tunnels because then you would have been able to survive the one going down. I'm like, well, we didn't even notice. It happened during a maintenance window, which is also not advertised. So it's like, how could we possibly have known? Node failures. So if the actual VM representing your Kubernetes node can go down, this can actually have a lot of, in our experience, had a lot of impact on the Kubernetes service calls themselves. So we had an incident a couple weeks ago where the node was in a bad state. It wasn't rebooting. It was never coming out of a good state. And nothing that was running on it was being rescheduled to run on another node. So what ended up happening was Kubernetes kept sending traffic to the bad node, and like 1 in 4 calls would fail, and we couldn't figure out why until we looked at the node. And that also was the genesis of a lot of those extra agents I was talking about to monitor the health of the nodes, because we wasted a lot of time looking for things that couldn't have been the problem if we just had the intelligence to know what was. And then I would say it's hard to justify paying for Google support, but we still do. So we gripe a lot about Google support. We send a lot of cases. We try to be very interact with them on a helpful level to try and solve them. But up until recently, there's really not a lot they could do. They don't have access to your projects. They don't have access to get into your data. And everything they could do would have like a sometimes 24-hour turnaround before they got back to you. And you're sitting there with a production outage. It's not really workable, right? I would say that recently they've come up with a way for them to entitle their support specialists to be able to go into your environment and do their own investigation. So you're not waiting on people collecting logs or doing things like that. They can actually do it themselves, which I think would have helped a lot in certain situations recently. Okay, the future. So this is what we're planning for about the next year or so. Hopefully we can get a lot of this in. So if you're using Kubernetes and you haven't heard about Linkerd, do yourself a favor, write it down and Google it tonight. It is a great piece of software that runs as a daemon set on every node. Essentially a transparent proxy that provides service discovery, routing, failure handling, retries, all the things that Kubernetes service itself should do well. Linkerd does even better. It also enables very easy deployments of canaries. So canary deployment is like you want to try a new version, but you don't want to fully roll it out. You kind of want to send some amount of traffic to it. Linkerd has a native way of used to say, send 1/4 of all traffic or 1/10 of all traffic to my canary deployment. You validate that it works, and then you kind of roll it out to the entire environment. We also provide end-to-end metrics and request tracing. So you do have to modify your application to take certain headers, pass them downstream through your application stack. But if you do that work, you can literally get a view. There's a tool, I think it's called Zipkin, that allows you to see the life cycle of your request. So if you go through 10 different services, external service calls, things like that, you see every step along the way, how long each step took, what the success rate was, when it had to fail, do something else. It's all like easily lined up. And it's a great way to do performance engineering and reliability engineering. It also has Prometheus exporting, so everything that you can see there you get for free in Prometheus if you use it yourself. We definitely want to move to multi-region setup. Right now we're not. We're just in one region. And this is to survive zone outages. I also consider going to multi-cloud. I considered using Amazon as our backup cloud or something like that. It's probably way further down the line. But in case you're wondering, like, look it up. There's been full zone outages in the last year. And if you're okay with being down for 4 or 5 hours, then okay, but we're not. We really need to be able to survive those kinds of situations. I talked about Chaos Monkey before, about adding some it's not adding instability, but it's basically testing your reliability of your application by randomly killing things. Another thing we're working on currently as well is continuous grind and performance engineering. So continuous grind is kind of a term I came up with where we have a cluster that's spec'd similarly to our production cluster, but it's spec'd to run 10 times or more the amount of volume that we're expecting normally. Ideally, what we'd like to do is make this part of our deployment pipeline, meaning that when you land a feature, it'll go through all the normal steps, and then at the end, it'll get to the performance pipeline. It'll get put in a performance cluster, and then all the scenarios that we expect this feature to perform as will then be run and come back with some sort of report saying that either you ran it with this standard deviation of normal performance, or it failed in this many times, what have you. The idea is that we know that right away before everything goes to production, we're not going to have a negative performance impact as well. And eventually, we'd like to put everything, absolutely everything, in Kubernetes as well. So we have Cassandra is the only thing running outside of it now, but with the new stateful set stuff that the Google guy was talking about, that might be a possibility in 1.7. I have some slides, some references to things I talked about, and a nice InspireRobot quote. If you're the only one who understands the universe, there's no need for the universe. That's why I'm here today. Okay.
Wow. Amazing.
Thanks.
Round of applause. I just feel very bad that this was the last talk because initially it's supposed to be the first one, but because we had to, change something on fly, but I think it's by far one of the best talks I ever heard in Kubernetes Meetup. So, round of applause. So for those who couldn't make up, we have recordings, so you can watch it again at home. We're gonna share the slides in the Kubernetes Slack channel. What else? This is just shows GKE is one of the best places to run by far, but still there is a lot of problems that you may encounter, and Kubernetes is evolving, and talks like that I think provide the good feedback. What you have to monitor everything still and do logging, and actually have feedback about Linkerd. So this is project kind of was very popular, but right now there's another project called Istio, which is going to be very similar in the feature, but it's going to be much more lightweight because Linkerd is written in Java, so it's like you're running heavy load.
Let's not start a religious war.
Yeah. So Istio is basically coming from the company called Lyft, the one that's driving, kind of Uber company. So they used very lightweight proxy. And right now, Google, IBM, Red Hat, and another companies that involved together in this project. So it's going to be alternative for Linkerd. So if you guys want to assess, that's going to be a good option. Yeah, I think we're good. If you guys have questions, I mean, I know everybody wants to go home. It's past 9, but I saw people were super interested in this talk. So if you have a question.
Are you using Stackdriver for any of your monitoring? And have you had any issues with the Google load balancers or any of the metrics?
Yeah. Okay, Stackdriver. We're using the logging feature of that, so all our application standard out logs are all consumed by that Stackdriver logging interface like I was showing. So it's very easy to go in and trace issues as well because all our components are just listed there. Load balancers, yeah. We have several cases, and I think they're all closed, but with Google about so the problem with the load balancers, they don't give you access to logs. You can't really see what's going on since they're all managed. And this can cause huge issues if you think the problem with the load balancer, but you can't prove it to your support guy that it is. What we ended up having to do in the past is we ended up just because we could have no other solution, we ended up just creating new load balancers in a different way, and that somehow magically solved the problem without ever explaining why.
All right, I think we're good. So yeah, I hope Mike will be also on our Kubernetes GKE Slack channel.
Yep, yeah, I'm there.
So if you guys, running GKE in production, we have Patrick just said that he's going to be helping us to answer questions, and Michael as well, right? Hopefully we can together help people to run Kubernetes. Yep. So I think thank you very much for this meetup. It's been 4 talks, and we really appreciate that you were able to digest this in this time, and it's summer, so hopefully it's going to be a little bit warmer. Enjoy the summer, and then we'll meet again in Q4 for another meetup. We're thinking to do the workshop, but we're not sure yet. So please stand by, and hopefully we're going to meet again soon. Thank you.